Hello friends, in this video I will explain you the concept of limits. So what is limit? First of all, see this expression. This expression is read as the limit of fx as x tends to a is y, right? This expression is read as the limit of function fx as x tends to a is y. Now, what is this limit? What is the limit of this function? Means what is this concept? To understand this limit, let us consider a function fx. Suppose this function fx is equal to x square minus 4 upon x minus 2. Right. Now see, the value of this function fx at x is equal to 2 will be 0 upon 0, which is an indeterminate value. So when x is not equal to 2, at that time fx will be equal to x plus 2, right? So when x is not equal to 2, that time fx will be equal to x plus 2. Now see, when the value of x is equal to 1.5, then the value of fx will be 3.5. When the value of x is 1.7, the value of fx will be 3.7. And when the value of x is 1.8, value of fx will be 3.8. When value of fx is 1.99, the value of fx will be 3.99. So when the value of x increases to 2, then the value of fx comes closer to 4, right? So as the value of x increases and moves closer to 2, the value of fx moves closer to 4, right? So this thing is called left hand limit, right? So this expression represents that x tends to 2 from left hand side, right? X tends to 2 from left hand side. So here in this case, the limit x tends to 2 minus fx will be 4, right? And it is called the left hand limit of fx at x is equal to 2, right? Why it is so? Because when the value of x increases and comes closer to the value 2, the value of fx comes close to the value 4, right? So the left hand limit of this function fx is 4 and x is equal to 2. Now see the right hand limit of function fx at x is equal to 2. So when the value of x is equal to 2.5, then the value of fx is what? It is 4.5. When the value of x is 2.4, value of fx is 4.4. When value of x is 2.1, then the value of fx is 4.1, right? When the value of x is 2.009, then the value of fx is 4.009. So here you can see as the value of x as the value of x decreases to 2, as the value of x is decreasing to 2, then the value of fx is coming closer to 4, right? So this fact can be expressed by this expression: limit x approaches to 2 plus is equal to 4. Sorry, x approaches to 2 plus fx is equal to 4. So this expression shows that when the value of x decreases and comes closer to the value 2, the value of fx comes closer to the value 4, right? And this it can be read as that right hand limit of fx at x is equal to 2 is 4, right? Now see, the limit of function fx as x tends to a is equal to L if and only if the left hand limit of fx at x is equal to a and right hand limit of fx at x is equal to a, though both are equal to L, right? So the limit of fx as x tends to a will be equal to L if and only if both left hand limit of fx and right hand limit of fx at x is equal to a, they both are equal to L. In case if the left hand limit of fx at x is equal to a is not equal to the right hand limit of fx at x is equal to a, then in that case what happens? The limit of fx as x tends to a does not exist. So the limit of fx as x tends to a will exist only when both left hand limit of fx and right hand limit of fx at